Hi everyone, welcome to a basically Docker 101 class or intro to Docker. My name is Tommy Parnell and I've been using Docker for the last 2 or 3 years or so. I'm a software engineer and I have a lot of friends who are also software engineers, and I've noticed over the last year or two they're getting more and more into Docker. They're asking more and more questions. Docker is getting more and more popular, especially now that Microsoft added support to Windows for Docker. So Docker is now kind of coming to the Windows ecosystem, and a lot of .NET developers are now asking me more about Docker and why they should use Docker and maybe what some of the advantages are and disadvantages. And I wanted to just show you basically how you can kind of get going with Docker, explain a little bit about it. We're not going to be talking about deploying any containers today. We're not talking about the cloud. We're not talking about managing multiple containers and crazy orchestration environments or scenarios. We're just talking about local development. We're talking about how it can maybe help you locally today. So let's pretend that. So before we begin, actually, let me just type real quick. Let me switch to my desktop. If you go to this URL here, I'll also link it below. You can download all of the course materials. It will redirect you to a Git repo that looks like this, and should be able to download all the course materials. If you don't want to watch this video, there's actually a little bit of a story that I wrote that you can read on your own, do it on your own. And this also shows you how you can install Docker on various platforms. So does the Docker documentation itself. But this is basically get you going. Now I'm here on Windows, but you can do this on a Mac or on Ubuntu. I'm going to use commands that will work both in PowerShell and in Bash, so kind of no conflicts or issues there. So don't be too concerned about the platform you're building this on. So before we begin, let's just pretend that we just got hired at this new company called BitMiner, and there's like a cryptocurrency mining platform, something or other, and you show up, you don't know what languages they use, you just show up to the interview and they say you're hired, and then that's it. So you come to work and they tell you, okay, to get started, it's really simple. You just type docker compose up, and in a few minutes, sometimes this may take a little while for you to get going. This is already running for me, but if this is the first time you've done this on your machine, it might take a little while to build up like a cache. But basically what we have is the entire system of BitMiner running locally. So if I go to localhost port 8000, which is the port it runs the UI on, you'll see a graph here, and this is basically all the coins that we're currently mining, like the Docker coins. So as you can see, we have quite a few coins coming in. Excuse me. And what you don't realize is this app is a .NET Core app, it's a Python app, it's a Ruby app, and it's a Node.js app. They're all separate REST APIs talking to each other. That's what makes the BitMiner system. And for someone like me who doesn't even have Python installed, I can't believe that I'm running Python right now, like on my computer. And it's doing this because Docker basically is like virtualization at the operating system level as opposed to like the hardware level. So in the past, when you would run a VM, the entire hardware was virtualized. But what happens with a Docker image is when a Docker container boots, it shares the same kernel as the host operating system beneath it, which means that it boots instantaneously, unlike VMs, which take a while. But yeah, it can still have dependencies the host OS doesn't have, such as Python or Ruby, that kind of thing. So this is obviously really helpful to get a big system to, like, this is 5 microservices. Docker obviously provides a great interface to getting all that running locally very fast and efficiently. So what we're going to do is we're just going to Control C out of that, which will tell Docker to basically stop all those containers. And it does take sometimes a minute or two to stop the services because, it has to kill the threads. I'm just going to clear my console here. So before, when we were running that, we were getting the console out of all of our services, and that was very noisy. So the first thing I want to do is redo the last command but add the -d flag. And the -d flag basically just says, don't show me the console out, just return me back to the like the console. So actually, if you can just give me one moment, I'm very sorry. I just got to turn quiet hours on. So if I run Docker Compose up the -d flag, the entire system is working again. There we go. Except now it's like I have free access to my console again. So what we want to do next is, you've heard that there's like a bottleneck in the system. So we have to go and find kind of the bottleneck. And that oftentimes can get very hard to do locally because you have to run multiple services. But Docker makes this quite easy. So the first thing we are going to do, we are going to turn up the workers. And if I move my shell down here, as opposed to being full screen, you'll see now that we have more workers, we're mining more coins. I mean, that's what kind of we would expect. So when we dial this like up quite a bit more to 20 as opposed to 5, we should expect like a huge increase, right? So obviously in the past, this was very hard to do as like a developer because, you know, running these things locally was very tough. But as you can see, when we added the extra 15 containers, we really didn't gain much performance. You see, like, we're not mining that many more coins. So there's clearly a bottleneck in the system. And you, just through like, you know, tracing stuff down and debugging, you come across this file. So an O1 bitminer in gen.py, look, somebody has added like a total bug to the system. Maybe it's actually like a slow function. Let's just pretend, obviously, this is a slow function, but you you delete that line 21. That's what it looked like before. You delete that line, and you then type docker compose up -d. We want to be disconnected -- build gen, and gen is the thing that we just edited. And if I do that, we'll recreate that one thing, and you'll see we'll have like a dip in our Docker coin mining, but then we'll have a much bigger boost. And it's recreating it now. So obviously, sometimes it takes a minute because it has to like destroy the old containers and boot new containers. Obviously, nothing's truly instantaneous, but as you can see now, we're mining exponentially more coins. You know, we clearly found this big bug in the system, and this is obviously like the strength of Docker is I can run this very complicated system locally, I can find bottlenecks, and I can fix them and see the results locally. I don't need servers outside my own machine. I don't need to wait on other teams or perhaps get my own servers in Amazon that costs a lot of money. I can do this all locally, which is really the big selling point. So I'm going to type docker compose down, which will stop all those containers and just kind of kill the system. So what we're going to do now is you kind of find out in the company that they're actually rewriting the whole platform. And the new platform is called the Phoenix platform. And, you know, they're very impressed that you found that like bug in the system. So what we are tasked to do now is to go and write Docker files for the other services. And so this will actually give me a chance to show you how you can actually build Docker images for services. So the first thing you want to do is cd up a directory and then cd to O2 Phoenix. And in case you didn't know, you can actually just do that and like backward and then O1. So I'm going to go from O1 to O2, just like that. So I'm in the Phoenix directory, and this is obviously the directory where the new services are. Now the rewrite is all in .NET Core. So previously it was a mishmash of Ruby, Python, and Node. Everything's now .NET Core except for the UI. It's still in Node. And you don't have to know .NET, by the way, to do this tutorial today, but we'll make a Docker file for .NET and a Docker file for Node, and you can go see the files that I made for Ruby and Python. They should like lend themselves very easy to follow, but you don't need to know any of those things today. I'm just going to walk you through kind of Docker itself, and we're going to try to remain very like language neutral. I just had to pick a language, you understand. So I'm going to actually close my text editor. I'm going to open a text editor here. I like to use Visual Studio Code, but you can use whatever you feel like. Atom is a great one, so is Sublime. And so the Phoenix project contains this gen service, which was kind of like the previous one we edited, hasher, store, UI, and worker. Basically, how the system works is gen generates like blockchain transactions, like hashes, like transactions to be processed. The worker will call into gen to get a process, and then it will use that process and call into the hasher service with it to get it hashed or like resolved. And then after that, it will send the data to the store. And after that, the UI can obviously read the data out of store and render the results. So obviously there can be like tons and tons of workers, and they all talk to these things independently. But they're all separate projects. And previously, Gen was Python, Store was Ruby, Hasher and Worker were .NET, and UI was Node. But now everything except the UI is .NET, then the UI is Node. So so the first one we're going to tackle is the Hasher service. So if I just expand that node out, and I'm going to make a new file, we're going to call it Docker file. Okay, and by the way, we're going to be working with what they call .NET Core, which is a cross-platform runtime that's Windows or works on Windows or Linux. So you don't have to worry about this being like specific to Windows. This is not specific to Windows. So in kind of all compiled languages, so actually this matters for Java as well, or C++. There's sort of like two, maybe not C++, but another compiled like JVM style language. But anyway, there's kind of two different packages almost for these things. There's the SDK, which comes with all the compilers, and then there's the runtime, which can only run like the code. And normally you would install just the runtime into your Docker container if you're going to deploy a container, because you wanted a container to be as small as possible. But when you're developing locally, it's actually easier to install one with the SDK. So Docker has this syntax. A Docker file basically lets you build a Docker image, which will then ultimately let us run a container off of the image. I know there's some like vocabulary, but just bear with me and we'll get through it. So, so most languages have their own images already. And here's the website for .NET. So this is hub.docker.com, which is like the npm or gem file or NuGet of Docker. So it's like basically a repository of Docker images, you would say. And there's one for pretty much every language out there. They all work a little bit differently, obviously, but Microsoft put out images for .NET. And my app is written on .NET 1.1.0. And like I said, we're going to be doing local development, so we really want one with the SDK. And I built mine with what's called Project JSON. And you don't have to worry about like what that particularly means. But basically what we need to do is we need to type from. And if we look very carefully here, here's the tag of the version we want. And so we need to do Microsoft /.net and then colon. So basically what we're saying is from this username, this repository in Docker Hub, and then a colon, and then we're asking for a tag, like a specific version. And we're going to do 1.1.0 -SDK -project JSON. And I'd just like to point out that these files, these Docker files, these tags don't use semantic versioning. They use their own kind of system. So these more accurately represent the versions of your language than they do the version of like the container itself. And what we want ultimately is we need to set like a working directory. And it's messed up here. It's just workdir. And I'm just going to copy and paste kind of what I had before. You can find if you diff the results branch with the master branch on the GitHub page, you'll actually find all these files. But we're going to add this project JSON file, which is kind of like the, Gradle or Maven or like maybe gem file of kind of .NET. It looks like this. It just kind of says like what dependencies I require, and then like download the dependencies, add all the source code, build it, expose the port that it needs to listen on. In this case, it's 80. And then this command basically will run only when the container boots to actually run our application. So to review, the from pulls an image. Working dir just adds a working directory. Add will add any file, or it could add a range of files. In this case, it's everything from the local directory into the container's local directory. Run will just run anything when you're trying to build the image. So we're doing that twice. Expose will let you expose ports on the container, and CMD is what basically runs when the container is booted. So if I just save that and I cd into Hasher and I run docker build period, which means the local directory, -t Hasher. And what that's going to do is it's actually going to run through all the steps in my Docker file. So if we just scroll up here, you'll see here, look, it downloaded this image, and then it set the working directory, and then it added the project JSON file, and then it ran .NET Restore, and then it added all the code, and then it compiled the thing out, and you get the gist. So the -t, so let's just like deconstruct this command real quick. Docker is obviously the thing we're using. Build, obviously, well, maybe not obvious, but it builds the Docker image. The period, local directory, -t, this just gives the image a name. So if I type Docker images, which is going to be a lot of images for me, by the way, you'll see that we have this one here called Hasher, and it's got an image ID, it's a SHA ID, and it says like when it was created and obviously the size of the image. And you can then like do docker run -p, and we'll just do 8080. So -p basically means when you run the container, map the local ports 8080 to the container's port of 80, and you can see in the container up here we're exposing port 80. So this 8080 will map to the 8080 in the Docker file basically. And -d, we want to be disconnected. Remember I said the -d was disconnected. And then we got to target a specific image, and we called that Hasher. And we get back a SHA ID. This is just a big long string of characters, and if we type docker ps, you'll see these characters here and these characters here are the same. And that's because we're actually running this right now. So if we go back to localhost port 8080, we can see here, look, we're totally running the service. So that's like how you work with Docker locally. The service is running. So basically what we did is we built an image, and then we booted what's called a container off of the image. We booted like an instance almost off of the image. And that's it. Like that's all it took to get our application up and running. So we want to like stop our application locally. Obviously we don't want this to run like forever, so we can type docker kill and then just type in some of the characters that line up with its SHA ID. You don't have to do the entire thing, and there we go. So it's now no longer running. If I come back here and hit enter, it's like, yeah, I mean Control F5, it's not working. And so as you can see, like it's the containers down. So I'll show you another example of like how you could do a node 1. So it's the same kind of deal. Here's the UI. We'll do the very same thing. Here's the UI project, and we'll add a Docker file, just like the previous one. And we'll go to the node Docker hub. So it's hub.docker.com/_/node. And this is the same kind of idea. I want I want node 6.9, which is also known as Boron, and I want to use Wheezy, which is a specific distro. And there are other ones too. There are on-build images which contain like huge npm caches, obviously making the container larger, but at the same time, npm installs run faster. So so you have to kind of pick and choose these things. But I'm going to stick with 6.9 and Wheezy. And there's actually a shorthand called Boron for Boron hyphen Wheezy. So in my Docker file, I'm just going to type from node : Boron Wheezy. And that's it. That will tell our image to base itself off of the previous image. You can actually pre-download this image by typing docker pull -t or node boron wheezy. And oh, I don't think I need the -t actually. There we go. Yep, just like that. And we're downloading the node boron wheezy image right now. It does take a minute to download. In the meantime, we can just keep on going with this. So I'm just going to copy the entire file that I have off to the side here. But basically, we're going to install Bower, which is a package dependency manager for the browser. Add our package JSON, which declares other dependencies that Node.js needs. Run npm install, which basically downloads our Node.js dependencies. Add our Bower RC file, add our Bower JSON, basically add our Bower configuration, install our Bower packages that we need, and then add all of our code, expose port 80 again, and then when we boot, we should run npm run start, which will obviously like boot the app. So same thing again, if I just save this and I cd to UI, I can do docker build -t UI, docker build, not built, it's build. And the same thing's going to kind of happen. I've noticed that this one takes a little bit longer to pull the images, so it does take an extra moment or two. See what happens. But this will basically obviously build the image again. And we'll just move on for now while that's running. So the other services obviously need to have Docker files, and if we look carefully, Hasher's got one, we know, UI's got one. The store actually already has one, so you don't need to worry about that. We need to get one for the worker and one for Gen. Oh no, Gen has one already too. So the worker is just missing one. So what we can actually do is we can, oh, I'll just let that run. We can if we open up like the previous project, we can get the code, the Docker file code from that project and just reuse it. Since it was already built on .NET Core, we can reuse it, but it's exactly the same as the other one, except this one doesn't expose any ports because this is like a console app or like a command line app. Doesn't have a web front end, but it looks pretty much exactly the same as the previous one did. Now what we need is a Docker Compose file. So in case you're not familiar, Docker Compose is a tool that lets you build multiple Docker containers and boot them locally in such a way that they can talk to each other and interact with each other if they need to. So it's a great tool if you have like what we have, which is multiple services that you want all talking to each other, and you don't want to kind of manage them individually through like Docker build on each image. Would be like a pain. You'd have to go cd into each directory, run Docker build, Docker run. It's a lot of work. So I actually already have a YAML file already to go on here. In case you're unfamiliar with YAML, YAML is kind of like JSON, only it's white space sensitive. So for example, this services node has gen, hasher, UI, store, and worker all beneath it. And these basically just declare different services for Docker Compose to run. So for example, the gen service must be built from the gen directory, and it looks for the Docker file there, and run it on port 8001, which will map into its 80. And same with hasher, run it on port 8002. And the UI has this funny one. The UI actually requires the database or the store for it to function. So we actually say link us to the store, and in store we obviously just build on the store directory, and the worker needs to talk to the store, gen, and hasher. So we say link those three containers together. And I bet you're wondering, like, well, how does this work? Like, what in code tells them to route to those directories? So if we quickly just look at the worker file, and you don't have to know .NET, but you can clearly see there's some HTTP commands in here, like this one. And basically what's happening is we're just requesting the DNS entry of store. That's all we're doing. And what Docker is doing is it's like actually basically like pushing some like DNS markers into the container so it can route appropriately to the store container, with some kind of magic that I can't actually explain. But the net result is obviously the worker can talk to these services just using a simple DNS name. We don't actually have to know how it works, which is like the nice part. So when we have that, we can go back to our shell and cd up to the root. So by the way, this Docker Compose file needs to be on the root of O2 Phoenix. And we can run Docker Compose. Let me check my notes real quick. Yep, Docker Compose up -d. So we'll run it disconnected again. And let's see. Oh, we're already using port 8000. Port 8000 is already allocated. And I don't know how it would be using 8000. So I'm just going to change this to like 8005. I don't know why that is, but that's okay. So we can now go back to our browser and open up port 8005, because the external port doesn't matter. And here we go. We are mining Bitcoins again, which is great, or like Docker coins, whatever you want to call it, Bitminer coins, whatever you want to call it. We're doing something, okay? And you know, we can totally scale up the workers again. Just like we did before. And they should boot, and the graph should update. Excellent, just like we expect. But when we made our fix to the gen service, that actual like bad code was ported over. People thought it was like a feature. So we have to like actually go back into the files and fix the Phoenix project so that it doesn't have this problem anymore. So I'm going to go to gen controllers, this values controller, and this line right here, line 22, we can just delete that right out there. And we can now type Docker Compose up -d -build gen. And here's something interesting. So you don't have to know anything about .NET, but what's happening is we changed code, and yet right now we're downloading our dependencies again. And Docker has a caching system that could allow us to change things at a much faster rate. Now, obviously, that was pretty fast, but to me, it was not fast enough. So we can come into gen, and we can look at the Docker file that we obviously didn't set up. Somebody else set up. And if we look carefully, this is adding all of our code, restoring our dependencies, and then building the project. And that doesn't necessarily make sense, because the file that declares our dependencies should be the only file passed in before .NET Restore. Because what happens is, if the previous commands like results haven't changed, then Docker will cache like the following command. So if, for example, if none of the source code changed here, then this restore would not happen. It would have just been a cached result. It would have, and thus been much faster. So what we need to do instead is we need to say add the project.json file in and run a .NET Restore, and then add everything, and then do a .NET build. And the big difference between those two is obviously if the project.json file changes, then we'll do a .NET Restore, and then we'll kind of add everything and build again. But if our project.json file didn't change, but our code changed, then also we would have to do is like build our code and then expose the container port again. We wouldn't obviously have to go back and re-download our package dependencies, and thus it'd be much faster. So the first time we run this again, it is going to re-download all of the dependencies again, because we actually just changed the Docker file itself. And so that's obviously going to be a little bit slow on the first hit, but then if we come back into like our code again, and we just make another change, like let's say we just put a whole bunch of new lines in, okay? That's like a non-change change, I understand, but we put a whole bunch of new lines in. Now when we do docker compose build, you see it went straight to the compilation, and look, it's already like about to recreate it. If we look up here, it says add project.json using cache because the file's never changed. So that's like very important that you really think carefully about when you build your Docker files, that you make them efficient. If we look at the UI one, it's very similar. We add things very individually. We add our package.json and then do an npm install. We add our Bower stuff and then we do a Bower install. Like, we're very explicit about just adding the parts that are required for those packages, which is very important that we like run on this like cache. So now that we've updated the gen service, we're like mining a lot more Bitcoin, and I think you have like a much better idea of how Docker works. So just a quick recap. Docker Compose is a tool that lets you run multiple Docker containers. You build a Docker container by first creating a Docker file, which will let you build an individual image using the Docker build command, and the Docker run command would let you run a Docker container independently, or you can use the Docker Compose up command to build and run a whole bunch of containers and glue them together. So I hope that this has been kind of informative for you. I think that for a lot of people, seeing some of the value in Docker, like some of the reasons why you would use it are, in this use case, are like very applicable. Again, I would recommend you go back through and look at all the code in the Git repo. Go back through this video, even like pause it at certain parts, mess with some of the commands, like look through all the commands. The story.md file in the repository should have like everything you also need to follow along by yourself. You don't necessarily need to watch the video. There should be some pretty good instructions. And if you like this, like tweet at me or submit an issue on the page and say that you liked it or whatever. Just give me a thumbs up. And if you didn't like it, then I could always use constructive feedback. So feel free to comment below, or send me a tweet, or whatever you feel comfortable doing. But I hope this really helped you kind of get going in Docker a little bit, and I hope that you have a great day. Please enjoy Docker and let me know how you get on.